This is Math, Chapter 11, Lesson 3. So we just got done with customary units of length, using them to measure and then converting back and forth between the different measurements. We're going to do the same thing in these next couple lessons, but now we're talking about customary units of capacity, which is the amount of liquid a container can hold. And so the customary units that we use for that are shown at the top of page 709 here. 1 fluid ounce, and they're giving some picture examples to help us, kind of picture in our mind what this amount looks like. And to me, that looks like a bottle of fingernail polish is about a fluid ounce. It's kind of hard to tell what it is, but that would be my guess is what that is. Then 1 cup, 1 pint. They show like the milk carton that you get at lunchtime would be a pint. Then 1 quart, that you can buy those at the grocery store, or 1 gallon of milk. That should look familiar too. And so these are picture examples of what each of those amounts would look like. And it's the amount of liquid that a container can hold. And so a lot of times when you go to the grocery store, you'll see these containers and there will be a label on how much is in this container or what size it is. And so now you can kind of get a good picture of what each of those looks like in your mind here. So if we go down to look at example 1, it says Jorge is filling an aquarium. And you've got an aquarium there. Which container should he use to fill his aquarium most quickly? So if he was filling one of these containers up and then dumping it into the aquarium, which one is going to get the job done fastest? Well, he could use any of them, but if he was using the cup or the quart, it would take quite a long time to fill that aquarium up, because sometimes these aquariums can be like maybe 15, 20-gallon tanks, depending on how big they are. So if he's trying to fill it the fastest and the most efficiently, he's going to want to use that gallon container there because it's the biggest one. So it says the gallon is the largest unit. It will fill the aquarium most quickly. So a lot of what this lesson is going to be is using some common sense and trying to figure out, okay, depending on the size of items that we're talking about, which measurement is going to be most appropriate. We did a little bit of that in lesson 1 with the measurement of lengths. We're going to be doing some more of that when we're talking about capacity today, and you'll just kind of have to think and compare these different amounts in your mind and kind of use what you know to help you figure out what the best choice is going to be. So if we go on to example 2, it says Nita is pouring salsa into a small bowl. Is the most reasonable estimate for the capacity of the bowl 8 fluid ounces, 8 cups, 8 quarts, or 8 gallons? Okay, now there's some things we want to pick out of here that are important. It's a small bowl, okay, and we're thinking salsa here, okay? Now, going back to what we know our choices are: fluid ounces, cups, quarts, or gallons. And the amount for each one of them is 8. So I'm going to just peek back to the last page for a second to help us picture this in our mind. If I was pouring a bowl of salsa, okay, I think the one that it left out, it didn't ask us about pints. But if I was going to sit down and eat salsa for a snack, would I be eating 8 fluid ounces of it, 8 cups, 8 quarts, or 8 gallons? So using our common sense, there's some of these that we can eliminate right away. I'm not going to sit down and eat 8 gallons of salsa by myself. I would be very sick by the end of that. Same thing with 8 quarts. even 8 cups is quite a bit. I don't think I could eat 8 cups of salsa in one sitting. My mouth would be on fire. So 8 fluid ounces, which you don't know this yet because we haven't talked about converting. That's the next lesson. But in 1 cup, there's 8 fluid ounces of liquid. So that makes sense. I could sit down and eat 1 cup of salsa, and it would be a pretty good snack, and I'd be done. The rest of them are far too big amounts. So it says the most reasonable estimate would be 8 fluid ounces. And the abbreviation for that is FL, and then ounces is OZ. And so sometimes you'll see on the side of a container, it might be abbreviated like that in the grocery store. So down at the guided practice, and we've got some problems that look like this on our assignment too, where they give me a picture of something that holds an amount of water, and I look at the choices and I have to choose the most reasonable one and eliminate the ones that don't make sense for what the capacity of this is. Okay, so we're going to go through the choices and we'll figure out the most reasonable one. For number 1, we've got a fish bowl here, and it's not one of those big tanks like was on the first page. It's just a fish bowl, so it's a little bit smaller. But my first choice is 1 fluid ounce, which it showed in the example was about the size of a jar of, a jar of fingernail polish. So I would say it's bigger than that. 1 pint, remember, was about the size of the milk carton you get at lunchtime. I think a fish needs a little bit more room than that to swim around. 1 quart, it showed, was the next size up. They showed that quart container of milk. I would say that could be a reasonable guess for this, but let's check the next one. 100 quarts, I would say, is way too big. This fishbowl is not that big. So the best, most reasonable guess for that would be 1 quart. And let's take a look at the next one. Number 2, we've got a pitcher of water. And so they're giving us choices here. Our first one is 4 fluid ounces, which would be 4 of those fingernail polishes, and that's actually the same as half of a cup. So I would say there's more than that in there. 10 cups, if it's a pitcher, that could be a good guess. Let's go look at the other 2 though, just to make sure. 400 cups, I would say, is a little bit too big. And 10 gallons, it's definitely not 10 gallons big. Okay, this is smaller than probably a 1-gallon jug of milk. So I would say the best guess would be 10 cups for that pitcher. Then the next one, we've got a can of paint here, and if you know the sizes that these cans of paint are made in, you might already know the answer to this, but let's look at our choices. First one being 1 fluid ounce. Now this is quite a bit bigger than a jar of fingernail polish, so I would eliminate that one. 1 cup of paint is not going to get me very far. I would say it's bigger than a cup, probably bigger than a pint. I would say 1 gallon would be the best guess, although you can buy a pint of paint if you're just looking to paint something pretty small, but usually if you're going to paint the walls of your living room or whatever it might be, you're going to buy at least a gallon of paint, probably a couple gallons, and those cans, those big cans that we buy, those are gallons of paint. So let's go on to look at some more examples here. We're going back to do some more multiple choice here based on the size of the container that they give us. So the first one being a swimming pool. Okay, now let's go look at these choices and figure out which one's going to be the most reasonable. Well, if I'm going to fill an entire swimming pool, I'm going to need more than 12 jars of fingernail polish. So 12 fluid ounces, I would say, is out. 1 gallon of water is not going to be very much water to swim in. Even 12 gallons, think 12 gallons of milk lined up there. If I poured 12 of those out, is that going to be enough water for me to swim in? Probably not. So 12,000 gallons seems like a lot, but that's the most reasonable here, especially if this pool is very deep. It takes a lot of water to fill a swimming pool. Number 5, we've got this bucket, kind of looks like a cleaning bucket here. About how much water do we think that holds? Our first choice is 2 fluid ounces. I would say it's quite a bit bigger than that. Remember, for fluid ounce, always picture that fingernail polish in the back of your mind. 2 cups. Remember that they have the picture of that measuring cup. I would say this bucket holds more than 2 cups. 2 pints, maybe, but usually our cleaning buckets are bigger than that because we have to be able to fit a mop inside it to dip it down in there and maybe mop the floor with. I would say it's probably bigger than 2 pints. I would say 2 gallons is our most reasonable there. Number 6, we've got, looks like a teaspoonful of medicine. Our first choice is 1 fluid ounce. I would say that's a pretty good guess because a teaspoon of medicine is not very big. But let's go look at the other choices. 1 cup, it's quite a bit smaller than 1 cup. Definitely smaller than 1 quart, and absolutely smaller than 1 gallon. So yes, 1 fluid ounce is our best choice there. Number 7, we've got a juice pouch here. Our first choice is 8 fluid ounces, which, remember, there's 8 fluid ounces in 1 cup. I would say that's a pretty good guess, but let's look at the rest of our choices. 8 cups, I think, is a little bit big. I don't think there's any juice boxes that they make that are that big. 8 pints would definitely be too big, and so would 8 gallons. So 8 fluid ounces is our best choice. Looking at this picture of a milk carton here, this looks awfully familiar and close to a picture example that they gave us in the beginning to start with, which was, it looks to me like the same size milk carton as the 1 quart, which was our first choice here. Let's take a look at the other choices though. 10 quarts, I don't think it's that big. There's definitely not 100 quarts there or 1,000. This would be a 1 quart carton of milk. Then we've got this glass here for number 9. Looks just to me kind of like a drinking glass. So if my choices, first one is 16 gallons. I don't think I've ever seen a glass that holds 16 gallons of soda. 16 quarts, I think is still too big. 16 fluid ounces would be a pretty good guess, I think. That would be 2 cups full of liquid. Or 16 cups, I still think is a little bit big. I would say 16 fluid ounces is our best guess there. So if you're kind of seeing a pattern here, for our really small measurements, fluid ounces are what we want to go with. The really big ones are the gallons. And then it's the in-between ones that you kind of have to think a little bit more about. Is it towards the smaller end and it's going to be cups? Or is it towards the larger end where you would want to use quarts? You just kind of have to use your common sense, use your knowledge that you've got about these amounts, and pick out the most reasonable. So going on to number 10, it says estimate the capacity of each object. And number 10 is a water bottle. So for this one, we've got all kinds of different sizes of water bottles. So it depends on, if it's one of your really big ones that holds a lot of water, or if it's a smaller one. But since a water bottle is a smaller amount, you're going to want to use one of your smaller measurements, either fluid ounces or cups, when you're using your estimate. For me, I'm going to say it's a pretty good size water bottle, and my estimate would be maybe 20 fluid ounces. Or if you had maybe 3 cups, that would be close to that also. Number 11, a juice box. You're going to want to go on the smaller end here too, either fluid ounces. A juice box is not going to be much bigger than 1 cup. Maybe I'll put an estimate of, let's say, 10 fluid ounces. If you look back up at number 7, their one there was 8 fluid ounces. Now for a sink, that's going to be a little bit bigger, and it depends on if it's a bathroom sink that's a little bit smaller, or sometimes our kitchen sinks are pretty big, wide, and deep, and they're going to hold a little bit more water. But I would go to the bigger end of measurements here, and I would say, how many gallons do you think you can fit in that sink? And I'll throw a guess in. If it was a kitchen sink, I'll put, if it was a pretty large one, maybe 10 gallons. Then number 13 says, is it faster to water 2 large flower pots using a 1 cup pitcher or a 1 quart pitcher? And this is kind of the same as example 1, going back to which of these would be the best container to use to fill that aquarium. Same thing. If it wants me to get it done faster, I'm going to want to use the bigger pitcher. So I would use the 1 quart pitcher, because then I don't have to go back and fill it as many times. It's bigger, so I'll be able to get done faster. Let's go take a look at some story problems on the next page. So for number 14, we've got this chart that we're looking at here. It says some household activities and the amount of water they consume are listed in the table. Use it for number 14 and 15. Okay? So it says if Callie takes 1 shower each day, is it reasonable to say that she could use 210 gallons of water in 1 week? So looking here, taking a shower, it says you can use 15 to 30 gallons in a shower. It seems like a lot, but when you stand there and let the water running, probably depends on how fast of a shower you take, but there's a lot of water that runs through there. And so, as it says, is it reasonable to say that she could use 210? Well, for this, I have to remember how many days are in a week, which there are 7 days in a week. And looking here, the high end of this would be 30. So if I use 30 gallons in a shower every day for 7 days, yes, I would use 210 gallons of water. So your answer here would be yes, because 7 times 30 equals 210. So that's definitely possible. Number 15. Callie brushes her teeth 3 times each day. She leaves the water running. Is it reasonable to say that she uses 2 cups of water in 1 day? Well, they're showing here that if you leave the water running, you could use 1 to 2 gallons of water. So, saying that she would use 2 cups is way off. That's not reasonable, because 2 gallons is much bigger than 2 cups. Number 16. Name 2 things in your classroom that can hold more than 1 cup. Estimate the capacity of each. So, thinking to things that are in the classroom, like, let's say you tipped your empty desk down onto the ground so that you could pour water into it. That would definitely hold more than 1 cup. to estimate the capacity of it, I would say you could fit maybe 3 or 4 gallons in there. Let's see, what else is sitting in the classroom that you could fill up? Well, let's see. The water bottles that you guys bring to drink could range anywhere from, the smaller ones could be like 12 fluid ounces, like those, I think that's what those little plastic ones are. Or if you've got one of your big ones, that could be 20, 24, maybe even 32 ounces of water. Number 17. Alexander estimates the capacity of a small soup can to be about 1 fluid ounce. Find and correct his mistake. Well, 1 fluid ounce, the example they gave to us was a jar of fingernail polish. I would say a can of soup's bigger than that. So I would say his mistake is in the measurement that he used. Instead of putting 1 fluid ounce, I would either change the amount of ounces or I would change the measurement that I'm using. So I would say it would either be about 1 cup or change this to about 8 fluid ounces. Then number 18 wants to know what's the difference between length and capacity, because those are the 2 things we've talked about in this chapter so far. Length is when I measure the distance of something or the size of it, how long is it, how tall is it. Capacity is the measurement of how much a container can hold, how much can I put inside it. So let's take a look at what our assignment wants us to do, and then you can get started here. So on the front page, just like some of our examples that we did here, they give you pictures of different containers, and you have to choose out of the choices that they give you which of these is the best estimate for that capacity that they're showing you there. So make sure you go through each choice to check and see which one of them is most reasonable, and you can always refer back to those example pictures that they give us on page 709 of the different amounts. Most of them are milk that they show there. Then on the back side, it says draw lines to match each object to a reasonable capacity. So you've got 5 different items there in 5 different capacities, and you have to draw lines to connect. There's only one correct choice for each one. And so what I might do is start with the biggest ones, like a swimming pool and a can of paint, and kind of eliminate them by the ones that you know are going to have to go together. And then by process of elimination, go down to some of those smaller amounts to figure out which goes with which. Then number 10, wanting to know whether or not 4 gallons is reasonable to fill a dog's bowl with water. So just think about the size that those usually are and how much 4 gallons is. Number 11 again is asking, is this a reasonable estimate, or what is a reasonable estimate for the amount of ketchup he'll need? And so make sure you're using the correct measurement there. I'm not going to use a gallon of ketchup for potato wedges. And then number 12 wants to know what's the relationship between capacity and fluid ounces. So you can look back to page 709 for some clues there. Number 13 wants you to put these measurements in order from least to greatest, so smallest to biggest. So again, page 709 would be a good help with that example pictures that they give us. And then number 14, multiple choice.